Hi guys, this will be the first of a few tutorials that I'm going to do. I want to try a new way of teaching and support your learning in architectural technology and detailing. So I'm going to narrate a series of drawings for you and clarify some things based on some of the critiques that we've been doing. So I just wanted to first contextualize the project again in relation to architectural design. So, and I wanted to let you know that we are focusing our efforts and our energy on, but also I want you to also remember certain things when you're doing this project, although it's not explicitly mentioned there. I think it's important that you always consider some of these methods. So if this was a typical design development process, you would obviously start, if there was, as you know, there are 5 stages of design. It's the brief, or it's in the inception. It's the concept. There's design development. There is technical documentation. And there is site supervision and contract administration, and then number 6 is closeout. Now, of course, closeout. Of course, this is where the building gets completed. This is where your building starts getting produced, and this is where you start collecting all your information and feeding your design process. Now, what we are focusing on in technology and detailing is we specifically focusing on the development component and the technical documentation. So I would say we work in this area where we focus on a number of things. We focus on the construction, how things get built. We focus on the structure and the design of that structure. We also focus on the detailing. We also look at the systems that you use, like water systems and storage systems, ablution systems, and SANS 10400, for example. But all of these things has an impact on the overall aesthetic and the form, of course, as well. There's an impact on the regulations. And this aesthetic and form is established over here in this area, which is what architectural design module is about. Now, the one thing I just wanted just to pull through into the area that we are working in is the following. We do know that when you are designing, there's a certain amount of information that you have to collate and conceptualize. There's the context. There's also the program that you need. Now, in this case, we gave you the program. And there's also things like what the client's requirements, and there's also technical information that you need in the beginning of a project when you're designing it, like zoning and setbacks, which we also given you. So we've given you that. The one thing that I need you to pull through on this project, which we find is specifically the context, is to pull this through all the way through to here, and you don't have to spend a lot of time on it. But I did give you the information. I did give you this information, and the information was as follows. The information is that the site is in Michalisburg. It's on a site that has got a contour that is slightly off. There's about 5 or 6 contours. 1, 2, 3, 4, 5, 6. So that means there's a from 0 to 6 meters, there's a 6 meter drop, and I've given you the dimensions. That means you can essentially equate the section to a real-time scale, which means that you end up with indicatively something like this, where each notch represents, of course, 1 meter. You will learn that in first year, and you end up with a site drop of about 5 or 6 meters. And we also mentioned that you're going to have a unstable earth for about 5 meters, which means your rock bed is sitting somewhere over there. So your building is sitting somewhere around in this area, obviously anywhere on site. But the reason why I'm reframing this is because there's a number of things that you have to consider, which we'll do within the next lecture, and that is the implication of the climatic context. This is very important because it relates to your north point. It relates to the sun angles, of which they are different in summer and winter, but also your contour is different. Your contour is slightly off the degree, the north degree, and this is a curveball I threw you because at this point you already have to start making certain decisions, and the decisions are as follows. When you're faced with 2 criteria, one being north, which means sun, which means view, which was a requirement, and 2 being the contours, which relates to a practicality. Now, this one's pretty obvious what I'm talking about, but this one, contours and practicality, we all remember the lecture on the idea that if your project sits on the ground, and the lecture regarding cut and fill, first you have an option. You have an option of your building sitting above the ground, which is a completely valid option if this was your building. But also you got an option of cut and fill, that the site angle is different when you cut perpendicular to the contour versus across the site. So this relates to which position your building is going to be lying. If you are deciding to put your building on the ground, if you put your building perpendicular to the contours or in line with the contours, that's the most efficient, practical way you can do it, and that simply means that the distance between each contour is longer perpendicular to the contour than at an oblique angle if we had to do it this way. If your building ends up sitting this way, the amount of cut and fill is marginally going to be more. So a less steep angle is if you build a building that, if you had to cut and fill this building, would end up reducing the amount of cut and the amount of work going to cut and fill. versus the angle of slightly oblique off contour, because the distance from year to year is different to the distance over there and there, which means that it's much steeper going at an oblique angle, which means that the amount of cut and fill that you end up doing here is going to be a lot more. So that's your first confrontation you have to deal with. Your building doesn't have to necessarily sit perfectly north, but you can still enjoy a view which is slightly oblique if your building's slightly at an angle. I think that's enough for the introductory lecture. Tutorial. Look out for the subsequent ones coming afterwards. Thank you.